a business case. We spoke about waste and differences between different materials and characteristics. So first thing you need to know is what's available. And it's not just the waste that you're generating on site. It's also what else can I use from external sources that are available in the local area, and how much. And we'll see that volumes are also important in terms of the savings that can be generated, because we know that we're dealing with high capital costs. Therefore, we need large volumes in order to try to offset as much as we can from the existing energy supplies. Where it's located, it's also important because there will be some costs associated with transport. And you know, if it happens that you have a good source of, for example, wood chips from a woodman that is next door to you, but the volume is not large enough, can I combine this then with other different sources to then have larger volumes? Volumes are also important and have to be looked together with what is your current energy baseline. So what should be your existing energy demands, and there is always a balance between how much energy you need and how much energy can be generated from the waste that is available. So those two things need to be looked together. There is also need to have consistent supply. There might be some variations in terms of the volumes, particularly with crop waste, where in some cases you've got a waste material that is only available for a certain amount of months during the year, and then the crop season is over, and then you're left with no waste. So again, what else can you use to then try to make the supply more consistent? Consistency also means consistent quality. If you have a range of different materials, how do I ensure that I get a good mix with consistent quality that will not affect my biomass process? The costs associated with that. Some materials can be perhaps freely available if someone is trying to sort of get rid of the waste from their process, and they're paying process costs. We're probably happy to give it to you for no price, but there's other materials that can also used in alternative markets, such as straw, which can be used as fodder. So there is going to be a price associated with that, and that price can also fluctuate with the market for these alternative products. As I mentioned, waste quality. So important to keep in mind that if there's any changes in moisture or hidden value, particle size, or the content of a certain hazardous substances, that can create a problem in your combustion or your anaerobic digestion process, can damage equipment, or can represent an environmental risk. An example of that is with treated timber that can be found in construction and industrial waste, can have arsenic. So it's these sort of materials, it's not suitable for biomass combustion, for example. Another key factor to consider is the what you already have in place in your process, what your existing infrastructure, and then how does the biomass technology or process integrates with your facility. The first thing is to determine the energy baseline, so it's quantifying what the thermal and electrical load is, because that then will allow you to size your biomass boiler or your digestion process to suit your thermal or electrical requirement. If you're thinking about putting a cogeneration unit in supply some of the electricity. What are the key energy uses? So what's the equipment that you have on your process that's using energy, thermal energy, for example, in the case of boilers and dryers, you use gas, and it's also exploring the possibility of co-firing biogas with your existing equipment. So instead of doing a whole replacement and putting a whole new biomass boiler, you might be that you just need to retrofit or make some adjustment to your existing burner and be able to co-fire. And then it's obviously, what energy are you currently using? It's natural gas or coal or diesel, and what is the cost associated with that? And that is particularly important to then determine the amount of savings that you can generate when you're offsetting these energy sources. And then are you already generating lots of waste that you need to treat or that you need to dispose? So there might be some opportunities to use that waste in a biomass or a biogas process. Technology options. It's again, how the technology integrates with your existing facility. When talking about biomass, it's really important to consider layout constraints, because the larger the size of the equipment, then it's not just the boiler that increases in size, but also all the storage and conveyors and handling equipment that is associated with that. So and that can require a lot of space. If you already have some constraints in that regard, then it becomes a barrier. Is the technology commercially available? For a number of these technologies, such as biomass boilers, there's a number of suppliers in Australia. So it's important to have that in terms of technical support and all that. Is cogeneration an option? So if you already you don't have a cogen and you're already paying high electricity prices, then it probably makes sense to if you think about generating biogas to fire a gas boiler, why not then maybe consider the option of putting a cogeneration that can offset some of my purchase electricity or reduce my electricity demand charges. And when we spoke about previously, there's some technologies that are more robust than others. We can cope well with variations in the quality of waste, but they're also more expensive. Cost, we said that really high capital cost, and that we're really talking about long-term projects in terms of developing the business case that needs to be taken into account. Access to funding is really important. We had in the past some programs from the government, such as the Clean Technology Investment Program, which is very good to finance some of these biomass projects. Unfortunately, that's no longer available, and we're still trying to see whether the direct action and emission reduction fund will provide some good funding options to for these sort of projects, but still a lot of debate, and the problem still being discussed in Parliament, so we'll have to wait and see. There's also other financing options, such as cheaper loans, from certain financial entities. One of them is the CEFC, the Clean Energy Finance Corporations, that can offer loans specific for these sort of projects at cheaper rates. And yes, the other aspect is, I guess, instead of replacing an equipment, is the retrofitting a good option, particularly if some of your equipment is reaching the end of its life, and you might want to consider a full replacement. In terms of savings, we spoke about energy savings, which is mostly thermal and electricity in the case of using biogas in a cogeneration unit. But there's also other savings in terms of the reduction in waste, which you're already spending a lot in disposal costs, or savings in terms of water. The water that's been treated from, say, the anaerobic process can be reused for irrigation purposes or other applications. What to do with the byproducts, whether I can, for example, sell it as a fertilizer, or in the case of the cogeneration, whether I can export power back to the grid. And the next one is really important, as I mentioned earlier, because of the high capital cost, if you can have access to large volumes of waste for a greater offset of purchase energy, then that will increase your savings and make the business case much more attractive. And the other key aspect is the differential price between what you call paying for purchase energy versus the cost of waste. So with natural gas prices reaching or going above $10 per gigajoule, if you have access to a really cheap wood chips, for example, at say $3 per gigajoule, then that differential will help you achieve the savings. Some of the risk, it's any regulations with the Environmental Protection Agency. So this is about making sure that you comply with air pollution limits and all that. The security of supply. So we're dealing with a contract to get a good source of waste fuel, because we're talking about long-term projects. You need to make sure that you have a supply for that time. So it's not always easy, but if you can get a secure supply for 5 or 10 years, that's obviously going to reduce the risk of the project. And also any price variations, not only with purchase energy, but also